You've been there, right? You're deep into a conversation with an AI agent. You've laid out all your project details, your preferences, and then, just a few messages later, it's like you're talking to a stranger. It completely forgets everything. It is so frustrating. But what if I told you the problem isn't the AI, it's the memory? So let's dive into how you can build AI agents that actually, finally remember. Man, this quote just hits the nail on the head. We have all been making this one fundamental mistake. We've been confusing a simple chat history with a real, functioning memory system. And that one simple mistake, it's the root cause of all that frustrating agent amnesia. All right, so here's the core of it. Most of us, when we start out, we treat the LLM's context window as its memory. That's the naive approach you see on the left, just one long, overflowing fire hose of messages. But the agents that actually feel smart, the production-grade ones, they use a proper architecture, like the one on the right. They treat memory as its own multi-layered system. It's not just a temporary scratch pad, it's a brain. So let's really break down why that simple, naive approach just completely falls apart. Relying only on the context window is like building a house of cards. Sure, it looks impressive for about 5 minutes, but it's totally useless for any real long-term work. See, context windows are, by their very nature, temporary. The second your session ends, or you hit that token limit, poof, that information is gone, forever. That means zero persistence. It can't learn from one conversation to the next. And to make it worse, as you stuff more and more into that window, your API costs go through the roof. This isn't a scalable solution. It's just a very expensive, leaky bucket. Okay, so what's the fix? We need a totally new way of thinking about this. We need a new mental model. And here it is. Memory isn't just one thing. Memory is an architecture. And this is the aha moment. This is the idea that transforms a forgetful toy into a powerful, persistent colleague. And honestly, this slide right here makes the whole thing click. The best way to understand it is with a computer analogy. Your agent's working memory, that's just like your computer's RAM. Super fast, active, but totally temporary. Episodic memory, which tracks what happened in the past, that's like your system logs. Semantic memory is the durable database, the hard drive full of facts. And procedural memory, well, that's its library of skills, the functions it can call on. So this is our blueprint for a really robust memory system. Now, let's peel back each of these 4 layers, one by one, to see how you build an agent that actually learns over time. First up, working memory. Think of this as the agent's active attention span. It's the current conversation, the latest tool outputs, all the stuff it's juggling right now. It's absolutely essential for the task at hand, but it is volatile. Just like RAM, the moment the power goes off, it's wiped clean. Next, we have episodic memory. This layer is all about answering the question, so what did we talk about last time? It stores summaries of past conversations and interactions. This is what gives an agent that feeling of continuity, you know? It's what allows it to pick up a project tomorrow right where you left off today without you having to explain everything all over again. But remembering events isn't enough. A truly smart agent needs to remember facts, and that is exactly what semantic memory is for. This is the agent's long-term knowledge base. It's personal encyclopedia. It stores those durable, lasting facts like this user prefers TypeScript or our customer's main office is in Kolkata. These are the things that should stick around forever, unless you explicitly tell it otherwise. And finally, we get to my favorite, procedural memory. This might just be the most powerful layer of all, because this is the how-to knowledge. When your agent figures out how to solve a tricky bug, that successful workflow gets stored here. This is what stops the agent from solving the same problem from scratch over and over again. This is how agents build actual, real skills. Okay, so we've got these 4 different storage layers. Awesome. But how does information get into them? And maybe even more importantly, how does it get out when you need it? These intelligent pipelines for writing and retrieving memory are every bit as important as the storage itself. A smart agent doesn't just blindly dump everything into a vector database and hope for the best. No, it runs a pretty sophisticated write pipeline. First, it watches an interaction. Then it pulls out potential memories and classifies them. Is this a temporary detail or a permanent fact? It checks for any conflicts with what it already knows. And only then does it store the high-value stuff with rich metadata, like timestamps and sources. It's a curator, not a hoarder. Now, getting memory out is actually even trickier than putting it in. Why? Because you can't just load everything into the prompt. You'll completely blow your token budget. Instead, a smart agent is surgical. It queries its memory based on what it's trying to do right now, pulls the most relevant info, re-ranks it all by importance and how recent it is, and then it loads a perfectly compressed slice of that knowledge into its working context. And that brings us to this huge insight. This whole thing, this memory architecture, it's really about context engineering. The real challenge isn't just storing terabytes of data. The hard part is mastering the art of deciding what tiny, perfect slice of knowledge needs to enter the model's very limited attention right now. But when you get this right, when all these layers and pipelines start clicking together, you fundamentally transform your agent. It stops being a simple chatbot and starts becoming a persistent, truly intelligent colleague. So let's just quickly revisit why that simple approach is so dangerous. Those naive systems, they just store tons of noise and duplicate facts. They have no clue how to resolve conflicting information. They have no policy for forgetting things that are no longer true. And over time, these systems don't get smarter. They actually get dumber. They gradually poison their own context with junk. So here it is. This is what that full production architecture looks like in motion. Your input comes in, gets processed by that fast-working memory, and then the memory writer intelligently figures out what's important and saves it to the right long-term store. Then, when the agent needs to think, the retriever pulls the perfect context, assembles a prompt, and sends it to the LLM. This is the loop. This is the engine of true learning. And that's the thing to really take away here. The ultimate goal isn't perfect total recall. A system that remembers everything is just as useless as one that remembers nothing. The real goal is to build a system that's part database, part ranking engine, and part summarizer, with an intelligent forgetting mechanism built right in. It's all about remembering the right things at the right time. And that's really the bottom line, isn't it? Without a proper memory architecture, you don't really have an agent. You just have a very eloquent, stateless function. It takes an input, it gives you an output, and it's destined to start every single conversation from scratch, forever. Building memory is how we finally break that loop.